we worked hard yesterday to get the interpreter pattern started, and we're kind of in this middle state. So we started off with original approach Swift enums, which use records and recursion, but don't use classes, don't have polymorphism. We've got an ugly approach that combines both those enums and the polymorphic classes, and our goal is to get things switched over to polymorphic classes only. And unfortunately, that actual transformation uh, disappeared when I didn't get the video started correctly. All right, so this I'll show you where we are, and you can infer the rest, I guess. Okay, so at the start of the day, parse was returning tree, and we added a little bit of a helper for empty expressions and error expressions, but we modified all these methods to basically return the new expression type. That's the type we're headed towards. And so rather than doing the tree.expression wrapping the value, we got everything so every class was wrapping. And then once every class is wrapping, there's no, we don't need the wrapping anymore. We can just do an unwrap. So we had a little helper function to unwrap and modify these things to return expression instead. So as it is right now, our parser is free of the tree enum. Okay, so now we're just trying to bubble that out to the rest. The next level out, I think, is interpreter. And I think, have I even checked this one in? I have. Okay, let's see. Can I get history? Parser returns expression instead of tree. Let's try this one. Okay. I was hoping for interpreter. I don't know if I can integer value type, convert custom value to current value. Parser. Okay. Well, yeah, there's parser. We were doing tree.expression of everything, and now we've gotten rid of that. And then let's see interpreter. The old one, interpreter. Oh no, we got to go back another one. Oh no, interpret takes a value of type tree. We call result interpret evaluative value. Okay. I think I'm on the wrong version here. Let's try this one. Yeah. Okay, so the original, we got a value tree.expression of expr. We bubbled it out so it's going to interpret with an expression. And we switched that to calling expression.evaluate. Okay. So now we don't need the evaluate method anymore. We just have print. All right, let's close this. Okay, so we just have the print, and we're kind of at this moment of trying to convert. Let's see if I can make the false step I made. Evaluate, we want int value. Okay, so we tried returning tree.expression. So I'm trying to get rid of tree on the return values, but I've got expression says you got to return a tree, and all its siblings return a tree. So if you're returning an expression, even though that's where we want to go, you're not hanging with the party. You're doing something else. We can't just return an expression. We have to wrap it in a tree.expression. All right, so let me make this done this way, and we'll see that an if statement is going to have problems with that. And that's our horrid if statement. And the one that really creates the trouble is this one. Okay, so if 3.float is not equal to 3.number, so basically the type of 3 is supposed to be converted um, to three. It should be converted to a float because the two arguments, it's a number and a float, should be a float. And instead we got a number, so we didn't do the type conversion on the joint type. Same thing here, I imagine. To float not equal to number. Yeah, so we checked left and right branch. Okay, so we can't just make that leap in one step, unfortunately. And where we left off is this ugly evaluate method that really should be so simple, but it's just not. Okay, so we get the condition, we evaluate it. If it's a Boolean true, condition to result as a Boolean. So this is the true branch and the false branch. So on the true branch, then we try and peel off and say, did we get an expression with an inner? And assign that to left. Left is an left is an expression right now. No, left is a tree still. So it comes in as a tree. If it's a tree.expression inner, then we're going to evaluate the inside. Okay, and we know it should be. I think we almost could just make that assumption. But we evaluate the inside, and then we're going to cast the type to the joint type. Okay, so the type is the type of the if expression that's calculated as this is your return type, regardless of your two arguments types. It's the joint type between them. So what's going wrong? So expression comes back in our new way. We said, yes, it is a tree.expression. It's a tree.expression with an expression. We evaluate that. It's really like maybe our result.cast is just not right. Okay. So we have a float. Maybe this is just not doing the right thing. So our inner evaluate comes back with a tree.expression with a type of its inner type. Let's find cast. Do you know how to handle integer expression? He doesn't really know how to handle expression. Okay, let's put that case in. Okay, and his type should be well, we're casting it to a new type. I don't know. So right now our value is tree.expression of the expression integer type. Okay. So I guess I could. So what's coming in is tree.expression of integer value, say 3 dot number, elm type dot number. Okay. So when that comes in, it's kind of we can't return self and get the right answer. That's for sure. Maybe we need to define how to cast. Maybe expression needs a cast. And it shouldn't be here at all. I mean, this is the old way, so we're going to try and get rid of this. If expression lets you cast to a type, I think integer value can... what should he do? If he gets told to cast to integer value, he's fine. I don't know if he gets called to cast to a float value. He should be a float value, right? If you say cast an integer to a float, you're committing that you know that it should be a float. Okay. All right, let's pull this out of here. Woof. So evaluate the type. What's that cast again? You take a type. If it's integer and it gets told you have a new type, he creates a new integer with that type. He's actually kind of okay with calling him an integer of type float. Okay, so let's do that. Again, I'm not quite clear where we're going with things, but if you ask for a cast to a type, you should get an expression back. Okay. And I'm going to say default is return self. I don't think it should happen, but let's get our case going here. Okay. And we'll override function cast expression. Okay. If you tell me as an integer to return a type, I said before my thing was integer value of value and the new type. And maybe this is more explanatory. New type. Okay, so how do you cast an integer value? You use the new type. Otherwise, you just default to whatever. I mean, I think that's the current cast behavior. I'm not sure it's exactly right, but we can debate that later. But I'm trying to refactor. I don't know. It's a stretch of refactoring, and I don't know. Maybe it's not. Maybe it's not quite legit. I don't know. We'll see. All right. So I expect to pass because I'm still returning tree.integer in 73. Okay, now my if statement, let's get it working. It's result.cast the type. What is the type? Well, the type is correct. That's our new thing. Result is a tree. And maybe I do need my tree thing here. If I'm going to cast result, it's a tree of expression, a tree of integer value. Okay, let's do that where I started. Okay, so if it's tree.expression, we never handled this before, and you got a value, then we're going to do tree, we're going to take value dot cast to type, and we have to we should have to wrap that. It should be complaining. I'm not sure why it's not. Okay. Let value. Yeah, cannot convert. Okay, so this should be tree.expression. So we're unwrapping it and then rewrapping it with the new type. Okay, I think that's okay. we will eventually get rid of that too. Okay, but I'm pushing stuff out. And the reason I do this, in this case, I don't know what we have, 150, 200 lines of code. We could go in here and go boom, 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 and fix the 10 places that are wrong. I'm pretty confident in that. But what I'm trying to do is explore the techniques that we could use if this were, 10 times as big. And I just never want to leave all the pieces lying on the floor for longer than a couple of minutes. So let's see what happens. All right, I think we're there. Okay. Just evaluate. Okay, that's progress. And is he saying integer 1 is not equal to expression? Tree.integer. Okay, this I would like to be an integer value. Oops. Integer value. No. Conflicting types, expression versus whatever. What value did we get back? Was it a wrapped? Integer 1 is not equal to expression. Oh, okay. I think he's getting this. Integer value of 1 number, that. Let's see. Oh. Okay, integer value 1 number, parenthesis. Okay. A little ugly, but I think what's going on is we're producing equivalent values, and eventually these will be stripped off when we get evaluate working in the final approach. Right now it's still a tree coming out, but we got one expression completely wrapped. Let's commit this. So migrate integer value to be the result of evaluate. Okay. If we did integer, we can probably do float. Excuse me. The cast, it defaults to self. That's what the other version of cast had. This, I think, can be. This should be able to be tree.expression of self. Okay. And we didn't have to, we did cast. I'm thinking we'll get a couple of evaluates that we're expecting float, the old tree.floats that are now getting tree.expressions. That's my prediction. Maybe just one. Okay. Interpreter expected 42.5 float, and it gets question marks. Okay. Excuse me. Then we put question marks up here on print. Okay. And I think I'm going to put a little helper message on here. Expression.print. Capital E expression. We don't have a print, but it's very similar to this, except the types inside are different. So it's not really substitutable. Unfortunately, I can't make a parent type that would do both these. That's really too bad. All right, and this is still going to fail because somebody's expecting tree.float and they're getting tree.expression. No? Let's see this thing. Interpreter succeeds. Oh, he's just checking the actual print value. Okay. All right, we really are on the downhill side, I hope. Okay, let's override custom value evaluate. Tree.custom value, value type. Okay, well, he needs a print. Okay, this time value is string, format type, all that's still good. But we're going to return tree.expression of self. And again, there may be somebody looking for a specific wrapped type. Let's see, this is when true. 3 float is not equal to 2 5 float. Well, that's not promising. 3 number is not equal to 2 number. Okay, something's going wrong with our if test. So let's unwrap this a moment, go back down. Yeah, so inner.evaluate on the condition. Inner evaluate is returning a tree, but now it will be a wrapped tree. So it'll be a tree dot expression of custom value, our new expression type. And let's see, this is Boolean thing. Okay, yeah. So once again, we haven't accounted for wrapped types. Okay, so if case dot expression, come on, tree let's return this tree dot as Boolean. Oh no, it's a true false thing. Okay, if it's an expression, the value is an expression type. The value is a custom value. If not value, well, let's do it the forward way. The value is custom value. Or no, I gotta, yeah, if value is custom value. No, it's, how about if value equals value as custom value? So if it is a custom value, which we expect, and then return well, this is a string. No, it's not. Okay. Okay, we take the inner expression. It's of type custom value. If that's true, then we should return custom value dot value equals true. Okay. Oh, did I put expression back? Okay, now let's make the swap. So you can see why I'm calling it refactoring. I'm taking a behavior, it passes. I'm trying to set everything up so it still passes. Yay. Okay. So we converted custom value. I'll trust myself to delete that. Okay. Next, I guess it's the moment of truth for this horrible if condition thingy. All right. So you get evaluates producing a tree. Result.cast. Okay. So condition is inner evaluate. It's like at some moment I have to convert everybody to return expressions. So inner evaluate, I guess the question is, does everybody define inner evaluate? Yeah. So as of now, all these leaf types, the custom value, int, float, they return a wrapped expression. And we are pulling it out. And eventually we return this result.cast. Now, result is a tree. Okay. So condition result. I would like to have an as Boolean on this thing, on custom value even. Oof. Oh boy. I don't know the best way to handle this, as is so often the case. Okay. Expression. It would be good if, let's try converting it so it stores these as expressions. That'll be a step forward, I think. Okay, equals. Whoops. Okay. Now, yeah, I was going to mess up these guys. Okay. But notice he's got an expression. He's wrapping it in expression to get a condition. Tree expression inner equals condition. He knows he would have a tree expression. So I think inner. Let's see. How can I do this? I'm going to do it slower. All right. Let's just get condition first. Okay. We got a bunch of expressions coming in. We're going to make the condition convert. Tree expression of inner equals condition. Then inner is condition. Okay. So inner evaluate is really condition.evaluate. And I don't think I need this if let. Okay. And we know it's going to be a tree expression inner because that's the only kind of expressions we produce. So I'm going to drop this. I'll comment for now. And these three, because this was a couldn't happen kind of thing. All right, so now I got the condition result. I evaluate it. I get back a tree. Yeah, this is good. Small steps. All right, now I can confidently delete this and this. Good. Now these two, because we evaluate both of them, I think we're going to have to do both at the same time. But let's just try one. We can see how it goes. expression is tree expression. Okay, now in here left, he's messed up. I could say tree expression equals tree expression, because instead of wrapping it up here, I'm wrapping it at point of use. But then inner is the same as left. Okay, so I think this becomes left.evaluate. And I don't need this, and I don't need these three. Okay, and let's see if that works. Yes, it does. And it's definitely starting to look a little nicer. Like the stuff we expect. All right, let's just do right. Right of expression. And now this is right.evaluate. And I can delete this. See, I get a little more confident as we go. Hopefully it's not misplaced. All right. Condition result. Okay, now we have a tree. Result is presumably like tree.expression of integer value. We call result.cast, which is over here. Oops. Where's cast? Custom value. Result is of type tree, and result.cast. Let's go there. Tree.cast. Okay. Is cast the value to cast the inner expression, blah, blah, blah. Shouldn't be that hard. Okay, what can we do? Well, at this moment, I think everybody who evaluates, let's check that. My theory is everybody who evaluates returns self. These things, they don't matter so much. Tree.evaluate. I think you should probably return self by default. On these. Okay, evaluate. Does this thing return a tree.result? Well, let's go back to cast. It returns expression here. I don't think this one gets called anymore. Well, let's see. Yeah, so he's not really used. Didn't mean that one. I meant. Okay, so everything is coming back from cast. They could be self. I could wrap it in expression. Let's try this. Cannot find tree dot. Cannot convert value of type tree to value of type expression. Okay, I guess that's all right. Let's go back to cast. See, I'm trying to get to the point where I can make everybody just say tree. Expression. And this one's the one that's problematic because it's returning a tree. Now, if everybody did their cast right. Let's see. So cast, usually it returns self. The only one that doesn't, we did integer. That's the funny one. Integer value cast returns a new integer value with the new type. And cast returns self. So I want to switch this. Yeah, let's do that. So I want to say I want to say left out of, I want to say result dot, I want to say result equals an expression. Now, right now, I mean, go back to this. If case let tree dot expression of value equals result, then I know I can say let. Oh, I don't need to say let value. I got value sitting there. Value at this point is like integer, float, whatever. I should be able to say return value dot cast of type. Okay. Build failed. Cannot. Oh, I'm gonna wrap it. So I dig out the value, cast it to the type, and wrap it up in a tree expression again. And I think that should be legit. And I think this should not be called at this point. Result.cast type. Let's return a different type. Let's return an error expression. Okay, let's do that. Well, no, we got tree.error. Yeah, let's do that. Oh, I hope everybody passes this one. That's the thing, you make these arguments. This must be doing that, and this must be doing that, and then you test it and find out whether it is. But that is okay. All right. So at this point, every evaluate returns a tree.expression of expression. All right, so I think we're ready to make this swap here. All right, so what I want to say is evaluate, wherever it is, I want to evaluate to return an expression. And that means I'm going to have to update some other places too. There's no way around it. Okay. But I'm going to try and do this in one leap here. Expression, so I can strip off all these tree.expressions. And again, they were scaffolding to get it so I could get everything compatible. And then once I have them, this is hopefully a good move. All right. Expression. All right. Condition result as Boolean. Result is left out evaluate. Well, result needs to be an expression. Expression has no member as Boolean. Okay, so let's wrap this momentarily. Tree tree dot expression of conditional result dot as boolean. Okay. Case let tree expression equal result. Yeah, we know now result result dot cast the type. Okay. Now we should see the callers of evaluate, which will be the interpreter, and maybe there's some tests. Okay. This result is now an expression. Okay. And I'm just going to wrap it again just to kind of let me get one piece straight. So I'm focused on the expression file. Can I get that right? Cannot convert. I think that's okay. Should be some tests. Okay, integer value test. Tree.expression. Now we get rid of that. And I'm thinking test should pass. I don't think there's any reason not. Okay, good. All right. So expression. Let's see. We got rid of tree. Let's find tree in here. Okay, the only one is that evaluate. Good. All right. Mostly remove tree from expression. Evaluate now returns expression. Okay. The problem is, like as Boolean, do I want that? Where do I want that? So I just don't know. My system type, like our custom type, is a little naive yet. It says I'm a string value out of this possible set of values, and as Boolean says, okay, well, I know you must be bool custom value true false, right? And if you are, then return whether you're true or not. Now, if you're not, if you're the wrong type, we just default to false and let things move on. I think that's probably okay. All right. Oh, let's see who's calling this thing. Maybe we can get rid of that. Yeah, Okay, so we got rid of one switch statement. Assuming this passes. Yes. Okay. Good. Now we're trying to get rid of as Boolean. It kind of comes down to what I want to do here. I guess I want to maybe I can pull this over. Let me do that. Okay, so let's define an as Boolean, and it's just a static function. It's going to take an expression and return a Boolean. Okay, and our tests are different here, but if well, custom value equals expression as custom value, okay, and otherwise return false. All right, so that corresponds to if we get a custom value, may only be declared on a type. We'll make it a helper up here. I don't know where Swift puts these things. Okay, expression. If the custom value is expression as custom value, let. So if it is a custom value, and then we need to know if the type, this part's the same. Except it's custom value. I think we gave a type accessor. Yep. Okay. Oh, it has question mark. Sorry, I've got another critical insurance call. Okay, if custom value, because expression as custom value, if the type is the proper type, Boolean with false and true, and the value is true, then we return true, otherwise false, and I think that should be the equivalent of this. Now we should be able to say condition result. Well, if we should be able to say as Boolean of condition result, okay, so one instance of type if expression. What? Condition result is condition.evaluate. As Boolean. Oh, I gotta. Yeah. Okay. Yes, I think that should be good. Result expression, we're calling the expression cast. Yes, now who's referencing this? Nobody. Okay, so we moved as Boolean to if expression, deleted dead code in tree. Okay. Let's see what's left on tree. Well, it's the expression. Does expression have tree anymore? We wanted to get rid of it there. No more tree and expression. How about interpreter? We got this little bit. Okay. Our print. Well, it would be nice. Let's convert it to an expression. And see what I'm doing? I'm just kind of moving this thing further in. Tree.expression, this should be value equals tree.expression of expression, and then I don't need it here. Okay, so in a sense, I'm pushing my types to be the right types on the outside level at the function declaration, I moved the junk inside, so I'm still wrapping it and unwrapping it and all that. But it's progress. Now, from the caller perspective, it's good. And from my perspective, if I have an expression, I mean, expression already has a print on it. I think maybe the better name would be as string. Let's see if we can rename these. This thing's a little flaky. Okay, and maybe I should be doing this custom string convertible thing, but I'm not there. All right, now my default, I think it should be, it should be, I don't have to have exactly the same message as the other. I don't really care about that error message. In effect, this shouldn't happen. When you evaluate an expression, you're always going to get something out, and the something is in charge of printing things. So let's put as string on these other two classes. And this is empty expression. I think excuse me, sorry. Let's do that. Okay, and then we'll need a subclass or a corresponding one for error. And in this case, we're just going to say error. All right, we don't do anything with errors yet, so I don't feel bad about that one. All right, I don't think that'll break any tests because we don't test for those either. All we've done with errors so far is just kind of detect it and bubble it up. And starting tomorrow, I guess, we'll take care of them. All right. So we don't have an ignored tree expression. These things, integer, float, custom value, all handle it. We don't have to worry about tree expression anymore because we don't produce those anymore. And I would like to just say, let's just do that. Let's output.append expr.asString. And I think that's all we have to do. Okay, and I'm hoping that works. I'm expecting it to work. I should say it that way. Yes, okay. I can delete that. And now our interpreter is becoming very minimal. And that's okay because I think it's going to be the interface to our front end, which we haven't done any work on. Right now we just say hello world. Okay, and expression. All right, let's commit this. So we make print, use the expression as string. Okay. All right. I think that's been another basically hour. So let's take another break, 2 minutes, 3 minutes maybe, and we'll come back. And I think we're going to get rid of tree. So see you in a couple of minutes. Hi, welcome back. All right. So I think let's see where we are. So we got rid of it in parser. We got rid of it in here. No tree. I don't need the test. Interpreter no longer uses tree. Let's find, there's probably some people out there using tree.expression still. So let's find those. I think we're probably wrapping and unwrapping. Okay, expected tree.expression. All right, let's make expected of type expression, which we already did. This does not need tree.expression. And this does not need tree.expression. else we got? Okay, I'm going to take matching case off. True.out expression not used. Okay. Who uses type? I'm hoping nobody. One assertion. Okay. Tree tests. Well, this would be a good test of our expressions. Do we have an expression tests folder file? We really don't. Okay. We got integer value tests. That's something. Let's make a float value tests. Whoops. Try and get these things in the right place. Float value tests. Okay. He looks a lot like integer value tests. And let's see that. Where'd that test go? Well, that one's okay. Parser tests. Oh, I lost it. Tree tests. Let's get those moved over here. Okay, so the tree test, check type, yeah. I mean, this is the test I'm after. Integer tests. So we'll take this one. And I don't know, is it expected actual or is it just two things? Yeah, it's just two expressions. I don't know what the normal one is. Integer dot type, elm type dot number. Okay. So you see our big case statement sort of implied a big test that was covering that case statement, but we're doing it down here this way. All right, and same thing here. This is a float value test. Test type. Tree.float.type. We expect to pass. Okay, tree custom value. Let's get custom value tests. Custom value tests. type. Bool type. Yeah, I don't know if we're saying this the right way, but okay. I don't think I need to worry about the ignored an error, but the if expression. Whoops. Let's try new file. Function test type, and we'll need that bool value again. So this type. Okay. Tree test.swift weak to delete. All right. Oh, he shouldn't be tree.if expression. He should be if expression of custom value, integer value, integer value. Okay. All right. For each node type, delete tree tests. All right, now let's look for tree dot. There's a few. That one's okay, I think. Parser. He's not an actual tree type. He's just naming the thing coming out of a parse, which is actually an expression for our point of view. These integer value tests. Tree integer. Oh, we just did this. I should have caught that. Integer value dot type. Float value and custom value. All right. No more tree dots. Let's see who's talking about tree. Tree parser tests. Parser test, that's okay. All right, let's see. Tree is out of here. All right, so get rid of tree enum. That's a good step. Oops. Let's do this. Convert to struct for classes. So this is, I forgot to record a couple days, I guess. 0210. The story, it's part of our handle if statement. Convert to struct for classes. Okay, yes. That was enum. To classes expression for the interpreter nodes. Okay. Make interpret produce a primitive result. I believe we've done that too. Interpret the if. Yes, we did that already kind of, but we fixed that horrible stuff. Okay. There's a little more cleanup to do, but that is a good step. Okay. The cleanup I want to do, I guess we are rearrange groups of files. So what we're seeing, like it's getting sloppy or hard to know, like what's the parser and what's the interpreter and all that stuff. So let's at least do parser versus interpreter. This is a new group. We'll call it parser. I don't know this preview content thing. I don't think we care about right now. Okay. And in parser, I'm going to at least put parser. And I think we'll put lexer and input and character categories. Okay. And then down here, there should be a parser test. We'll just call it parser again. Parser. Move below that stuff. Parser. Lexer. Character category. And I don't have an input tests. Okay. Let's build this. Actually, I should clean it. Just once in a while with Xcode, there seem to be some cleanup mistakes. So just because we're doing renames and moving around, I want to make sure the old one isn't being referenced somewhere. So. Clean, run. Okay. Nice. And then let's pull a new group for interpreter. Interpreter, okay. Top level. And we're going to put all these in there. Interpreter, I think Elm type is kind of a prerequisite. Interpreter, well, maybe interpreter at the top, I guess. Okay. And down here, same kind of thing. New file, new group. Enter. Get out of the way, you. Okay, interpreter tests, Elm tests, integer, all these. Okay. Clean, build. Good. All right, and now let's take a look. Okay, expression test. I don't think I need the tests, custom values. I just want to look at the interpreter. Okay, that's pretty minimal, too minimal. Let's look at expression. I think I need to pull these things out. So let's do that. Empty expression. Error expression. Okay. Integer value. The good news with this is it makes it easier to just kind of change one place and not worry about all these others. The bad news is it's a little harder to spot duplication between them and a little harder to find, but I think on the whole it's worth doing. Float value. All right. Custom value. Oh, I learned to cut first. And if expression. Extract each interpreter node to its own type. File. Okay. What else? Oh, content view, those don't matter. Yeah. Okay. We did that. All right. Now, I feel like we should take a break, but it's just because we're mentally shifting gears, not because we just had one a few minutes ago. But I definitely, I don't know, I got these physical things, and I think I partly train myself to get them, and I partly just get them naturally. But, you know, it's like, oh, this relief of getting this tree this tree out of there. And now this is how it works: is tokens turn into expressions, expressions turn into strings. And I don't think we need the word behavior there anymore. Okay. And that's kind of the high level, that's our high level design right now. We have the lexer does that, the parser gets the tokens, and then we evaluate the expression. And it's a little weird, like the parser has to know these node types because it's creating them. Yeah. And then it's really the nodes that are the interpreter in effect, because each node knows what to do. All right, let's see. So I think our next move is this error handling. Excuse me. The deal is, I guess we can close these things. And let's get our lexer up, because things start there. So what happens is you can have situations that result in an error. Let's find one. Here's one. Minus or end of line comment. So if you get a minus, you read it, and you see a second minus, then you have basically you're turning it into a new line because you're commenting it out through the new line. If you see anything other than a minus, right now we don't know how to parse it, or we don't even know what it means, so we just say it's an error. But the fact is, like, we should be telling you error at line 3. Okay. I'm not 100% sure where we want to track this, but what I want to have, I would like to have a location, at least for, well, I think, well, at least for the errors. We know we need them for that. We need to deal with new lines. A new line, when we see a new line, we should be increasing the line number. So that much we know. And it's, where is the line number going to be maintained, I guess, is the question. Right now, well, it's two questions. The other one that's on my mind, this token character, as we go through for some entries like number and name and things like that, we accumulate this token. And in a string, I don't know, really, like, we don't really need to put the characters in the string. We'll see where we do that. Number. I had some keeps. Yeah. So keep preserves this thing in a token, but I don't think I need to. I could just let my input stream keep track of that. So I don't know if that's a good idea or a bad idea, but let me put it in my to-do items. I don't know if this is more of a refactoring. Should my input handle token or leave it in lexer? That's kind of the question. All right. So my bare minimum, I guess, for now, is if you get an error, you should be told the line number at least. Now, the line number, I guess if you knew the line number, well, another thing on my mind is, should every token know its location? I don't think we need it so far. I'm imagining we put out something like, oh, line 7, column point to this. Here's the error. And there's maybe it should be wrapped in like a location type or something. You could imagine needing a file at some point too. Yeah, there's no need to imagine it, I guess. You definitely could need a file at some point. If it's a REPL read eval print loop, yeah, there's not really a file, you're just typing, but they can reference files. You can import other modules. So the location, let's see, here's that minus or element. What else says an error? Okay, end of file inside your nested these things. Your nested comments. My brace dash. You'd like to say you'd like the error to attach to the comment. I mean, to the start. Really? Well, I'd kind of like to do on the inner thing. You find an input in the inner one, and he returns error, and we bubble out. That's probably okay. Well, we don't return that token. And we would get it coming back around the loop again. Only the top level one would know it, I guess. So what's the assertion, right? I guess the assertion is, like, maybe we start here. Anybody who can produce an error token, we would like to check that the line number is the correct line number. Now this one eventually probably goes away because minus is a legit operator. We just don't handle it yet. This one does not. If you have an end of file and a token, that's just a flat out error. You can have it digits. You could have... Okay, yeah, you could have a malformed floating point number. That's true. And these things could contain strings too, and tell you what the problem was, since we're mucking around with them anyway. All right. Can I rename that case to error old? Do error old, error new? Or do I just change them? Okay, so let's find a parser test. A lexer test. All right, where's our minus? Digits, spaces, new lines, comment, end of line token is okay. Wow, I don't think we're really checking errors at this point. Oh, here we go. Unterminated nestable comment returns an error. Yes, that's... let's get this thing, give it a message at least. So that the error is unclosed comment. Okay. The error is float needs digits after decimal. Float needs digits after exponent. I guess we won't read about that case. Okay. I think this is still the same case, maybe. All right, so this shouldn't even build. Okay, let's put a string message. Somebody else should be complaining. Enum case error has no associated values. Interesting. Oh, here we go. Token does not conform to protocol. That should, oh, you gotta write it in Swift there, dude. Message of type string. Okay. These things. See, the errors are backwards. They should be on the Lexer side. Yeah. Okay, so we need our message for those, and I could have done those separately. Probably should have done those separately. We'll just put junk in for now. All right, that's kind of stuff I want. Unclosed comment does not equal EOF. Unclosed comment is not equal to EOF. So if you read this, you get EOF. Interesting. That seems wrong. Why did he get a token.eof there? You would think that would have triggered. Okay, let's see the others. Who else? Lexer.get. Okay, our X is error. Digits after decimal. This one is the Y error. Another Y. All right, let's see if anything other than the unclosed comment. All right, oh, one up top. Oh, that's okay. Error unclosed comment is not equal to end of file. Unclosed comment is not equal to end of file. So lexer.get returned end of file. Oh, which he should. No, we got token.error before though, right? Let's double check that. Okay, well, we are out of time. We're going to end on a red test, so next time we'll come in and we'll know exactly where to start. Next time is tomorrow, Thursday, 1 to 3 p.m. Eastern Time. Hope you can join me. I apologize again for missing the first part of the broadcast. Hopefully the little catch-up helped, and I will see you in the future. Take care. Bye-bye.